So yeah, I guess I can see why he's doing this. The x plus y plus z. So he's saying, okay, in this we're saying, okay, I'll draw a little picture first. So polyprotic, what does that mean? Just to make sure we understand.
Can give more than one proton.
Yes, it is capable of carrying more than one, right? Now, of course, when we look at it from the acid's perspective, it can donate more than one. In the base's perspective, it can accept more than one, right? So we got H, in this case it's H3PO4 it's showing. H3PO4. And, I mean, it has the potential to become this. And it has a negative charge, right? Because it lost a proton and positive charge. I'm sure you guys understand that. H2 minus, and this, okay. So, it can do all this, and it can go the other way, right? Does everyone understand that idea as well? The fact that it's a weak acid, right? Or a weak base, it can donate and accept again. Whereas strong would be, if we said strong acid, then that would mean it would donate and never take it back, right? Everyone understands strong and weak? Because that's important. These elementary ideas. So, if we take then H3PO4 and stick it in here, is it just going to dissociate to become this? And that's all that's going to be in the solution. So kind of describe to me what's going to happen in this. In the same beaker, right? We stuck one particular kind of molecule in there, right? And of course this, I'm not just saying, I guess I could just say one molecule, but a whole bunch of it in there. What's going to happen?
Aren't you going to have all four of those in there?
Yes. Now, how come? And I mean, it's a simple idea, but I mean, just kind of think it through in terms of like the steps. How about that? So all four will be there because, well,
it keeps just dissociating.
right.
That word is.
You simply stick it in there, it becomes this. This has then the possibility to become this. And then this has the possibility to become this. But now here's a question. If this has a certain amount of strength, so we think about the strength of it, we know it's weak because it's not a strong, right? You've memorized the strong. Mm-hmm. Have you guys been working on that? Because that's important. Memorize those strongs because then you can look at anything and be like, well, that's not one of the strongs that I memorized, so it must be a weak acid. And that's really the only logic you have to figure out the difference between weak and strong. And then you have to use, in comparison to weaks, you got to think of their K values, right? The bigger the K, the stronger the acid, right? Or if you think of the base's perspective, the stronger the Kb, the stronger the base. So if we're thinking in that perspective then, okay, well, this guy, if he dissociates to become this, so he lets off an H to water and becomes this, how strong do you think this guy is in comparison to what he used to be?
Not as strong.
How come?
Because I lost an H.
Because it lost an H? Okay.
It's already a weak acid and already dissociated somewhat, so it's just weaker.
Yes, okay. I mean, logically we can reason through this. I mean, anyone else want to say something else about that? Because if you think of, I guess, a individual who has a lot of money. Let's say it's not a lot of money. Let's say it's like us. Let's say we were lucky and got a nice job during the 7-week break and we collected a lot of money and now we have enough money to be able to get through school and even have a little extra. And you decide to budget it out and say, I'm willing to give this much money to charity or something. I don't know. So, of course, you budget that out and you give that money. But let's say you have a friend who's asked for that money or asked for some money because they need help. And of course you're like, well, of course I want to help you, but I can only give so much. So you began with a certain amount of money, and as you keep giving it away, you're not going to want to give more and more and more away, right? Because it gets harder and harder and harder, I guess, because you need money. So you can, that's a silly analogy, but it's just the first thing that came to my head. You the more that you give money, the less that you're going to give if you don't have very much to begin with, right? So it's the same idea. This is a molecule altogether that has a certain amount of stability. The more H's it keeps giving away, the less stable it becomes, meaning the more it will want to hold on to whatever's helping it be stable. Because if it keeps letting go of H's, it's going to, you notice its charge is changing more and more and more, right? Well, it's becoming less and less and less stable. It doesn't like being in that kind of state, if that makes sense. In the basics perspective, if you think of like this, you don't ever see this by itself. You see like a solution of something like this, right? So if it was a solid or a salt, it would be associated with some sort of metal or something, a cation of some kind, right? You stick it in water, then it dissociates to become this, right? And then we have this. But this guy, and I don't necessarily know how strong he is in terms of a base, this guy will then start reacting to become HPO4, 2 minus, and then H2. It'll go the other way, right? It'll start reacting with water. So same idea. And I guess, like I said, we don't know if he'll want to become these really well, I guess if we had a K value. But we could assume that if we stuck this in first, what is going to happen is we're going to have a lot more of these than these. As it keeps going this way, the concentration keeps going down and down and down and down and down because of how much it doesn't want to let go of that H. And I would assume it would be the same the other way. If you stuck this in first, you'll have more of these than these, right? Okay, that's conceptually then. So now what this whole entire chart is about is now mathematically solving for exact concentrations and numbers and stuff. So the conceptual idea is just this. Is everyone following okay? I mean, now we're just going to use basic ideas that you learned in chapter 14, which was ice tables, and talking about K values, right? KAs and KBs and stuff. So the confusing part is that there's multiple ice tables because we have more than one reaction taking place, right? So there's going to be a possibility for this to become this, and for it to go back, this to become this, and for it to go back, and this to become this, and for it to go back. So there's 3 ice tables. Hence it's like this. And we've already conceptually understood that as time goes on, as it keeps letting go of another H and another H and another H, it will get weaker and weaker and weaker, which means the amount of H's it lets off is going to be less and less and less. So we think of this X, H3PO4, and the amount it dissociates first. I'll probably just write it up on here. Remember, I'm going to say, here's a little solution which H3PO4, and we stick it in there. This is what's happening in there. This whole entire thing. So just to conceptualize that.